This conference will now be recorded.
So guys, we'll begin with something known as TensorFlow for the day. So in my previous session, I did guide you to install the TensorFlow. I don't know how many of you are facing the challenges with the installation of the TensorFlow, but this is a very stable platform to be installed, okay? So you need to ensure that your some of the libraries which you have already installed with your PyCharm, they should be kind of on a latest version, right? So you update the libraries in case you are facing the challenges with the TensorFlow installation part. But this installation with the TensorFlow is just your pip install TensorFlow. All right, so guys, this command you can say, right, pip install TensorFlow. And in case you are having some of the issues, you can even just try saying hyphen upgrade the pip first, right? Because TensorFlow always needs the latest summaries here and there. So make sure that you have the latest pip installed, and thereafter you can do this. So even if you are unable to go ahead with this pip install TensorFlow, then lastly you can try with TF nightly, but this is kind of a bit unstable. Now TensorFlow needs your machine to support CPU and GPU, right? So there has to be these two things available in your machines. If you're trying to run TensorFlow in very old machines, it's gonna be a challenge for you, all right? So you won't be able to somehow work on that way. So TensorFlow will not only work for Python. So for Python, it's like by default, majorly for Python. But we do have Java, we do have C, we do have Go, where we can work with the TensorFlow at the same time. All right. Now TensorFlow is a framework by the Google, right? It's an open source a framework for doing your deep learning solutions, right? So you can have your AI-based solutions here. So sklearn was primarily focusing on solving the problems by making ML models, right, through the mathematical approach. But here, when it comes to the TensorFlow, so here you're trying to use artificial neural networks to solve your problems. So the models remain same. What I'm trying to say is that the classification regression problems, they are same problems, but we kind of slightly change the approach to solve it, right? We use neural networks to solve the problems basically. So the first thing first is you need to install your TensorFlow. So I'm just going to write one Python file here. So how you can work and cross check your TensorFlow, guys, right? So for your TensorFlow, I'm just going to say import TensorFlow as TF. So print me the version of the TensorFlow, right? So underscore version underscore, right? So you can just run this program. So here you are with 2.1.0, and it means that TF TensorFlow is successfully installed and you can exactly work on it, right? So before I proceed, right, I would just like to know how many of you are getting challenges with this installation? Right, so guys, you need to install this first, right? So installation links, I'm just gonna put here only. So this is the installation link. These are the installation commands. You need not to fire every command, right? You just fire the first two commands. So what I'm saying is that your pip should be updated and then you install this part, right? So requires the latest pip, and we need to have this current stable version for CPU and GPU. You need to say pip install TensorFlow. That's it, guys, right? So let us share the errors in the groups, guys, right? So you need to share these errors in the groups. Once again, what I'm saying is that your machine should be also compatible with the TensorFlow. Your laptop should be compatible with the TensorFlow. Cross check the configurations first, okay, before you do the installations. The other way around is that you can work in TensorFlow, the collabs, or the, you can say, the code labs provided by the Google, right? So you can even work on them. So we have to come up and somehow see this learning part of our TensorFlow. So it's not only how we are going to proceed with TensorFlow. So I'm going to even teach you in art, right? That you have to somehow how you can explore a framework basically, right? I'm just going to even put up this part as well. So Puranjit, yes, the TensorFlow is so these errors, I think I have to take them offline, right? So Shashi Bhushan, so your DLL is basically somehow not available, so you need to install that separately, right? All right, so guys, so TensorFlow here. So I'm gonna click on Learn More. So you get to see these tutorials here. So tensorflow.org/tutorials, right? So here you are with the tutorial link. Right? So these tutorials are shared here. So you need to follow these tutorials first so that you get some hands-on what is TensorFlow and how you can work with them. But I'm just gonna first of all put some basic programs here and there, right? I'm just gonna write some basic programs and I'm gonna come up and show you how we can solve the problems with the TensorFlow. Now, for an instance, right, I'm just gonna create this simple variable called hello. So I'll say TensorFlow dot constant, right? So this constant is going to be a string for us. So hello from TensorFlow, right? So I just create a constant here, and I'm going to print this constant, which is your hello. Let's try to run this program and see what happens, right? So the moment I execute my program, it says it's a tensor, tf.tensor. So there is a string called hello from tensor. The shape is none and the data type is string for us. At the same time, what you see is that the TensorFlow is kind of giving me a warning or an error. It says your CPU supports instructions that this TensorFlow binary was not compiled to use AVX2FMA. So what should I do now, right? So you'll get all these errors here and there, and in order to come up and solve them, you need to search them on Stack Overflow. So what I did, I searched this error, and the solution for this error came out to be as in that you import OS, and thereafter you say OS dot environment. In the environment, so there's a list in the environment, and there is this flag called TF underscore CPP underscore minimum log level. So I need to set this minimum log level to 2, and it's a string basically. So the moment you set this guy minimum log level to 2, right? So my system will now give no error, no warnings here. It's just gonna focus on the solution. So we have our different machines, different systems. There may be 32-bit issue, there may be 64-bit issue. You need to work on that, right? So TensorFlow won't work on 32-bit. TensorFlow will only work on 64-bit. You need to just cross-check your machines and see how the things are, right? It's not just that you have to blindly come up and say, okay, we are unable to work on TensorFlow. Do some rigorous analysis on it. So let us see very basic introduction to TensorFlow again. Right, this was very quick one TensorFlow setup check. How you can write a constant in a TensorFlow. So I'm gonna write this session 55A. So what exactly is a tensor, right? So what is this term called tensor? So guys, tensor is ND array. It's very simple for us to understand. So when you understand this mathematical term tensor, it's an n-dimensional array for us. So do not get confused, right? That tensor is something else. So when you said that np dot array, it was also a tensor. Now I'm going to once again import this TensorFlow as TF. So let us try to create some constants, right? So I'm gonna create a constant, let's say a matrix A. So I'll say a TensorFlow dot constant. Now TensorFlow further is going to have two different versions, right? So if I'll say TF UC dot compact, right? So V1 and V2. So there are some APIs available in V1, some in V2. So this constant is to create a constant in TensorFlow, right? So I'm going to create this constant, which is going to be an array of arrays or a list of lists here in Python. 1.0, 2.0, then 3.0 and some 4.0. So this is going to be a list of lists for me, right? Same way, I'm going to write another B, which is going to be a constant again. So let's say it is 1 and 1, and let's say this is 0 and let's say 1. So let us try to say print me A and print me B. So previously you created the constants as strings, and now you are creating these constants as some floating points for us. Right, so here we are, guys. So this same error will keep on following us. So what I can do is I can anytime use this my OS solution here. So here we go. So two constants A and B, right? And the data type is kind of tensor for us. I mean to say the type of A and type of B. The shape is 2 and the data type is float 32. So your TensorFlow is something where you are working on constants or you are working on arrays, and these are very basic introduction, right? For example, I want to do this matrix multiplication. So your TensorFlow will give you the APIs to do so. All these mathematical things can be taken care by TensorFlow. So I can say C is your TensorFlow dot matrix multiplication for A and B. Now I'm gonna come up here and say print me C as well. So guys, I hope this is clear to everyone. Can I get a smiley as an acknowledgement from all of you? So you can even try this same by saying the approach as in your A is your TensorFlow dot constant. Let this be a 1D array. So your B goes like 6, 7, 8, 9, and the 10. Right, so I can say that there is C, which is going to be your TensorFlow dot multiply A with the B. So the way we got NumPy, right? In a similar way, you got this TensorFlow. Nothing much challenging here. But what I want to bring in here is that during your exploration on TensorFlow, you may find something known as session API. So I just wanted to come up and show you what is meant by the session API. Now, there may be a case that you will find certain solutions written in this manner. So there may be a case that you will see a session is your TensorFlow dot compat dot v1 dot session object. So you create an object of session. So once you create the object of session, right? So thereafter, this printing of C here, the printing of C which you can see, which we did, right, can be done by creating a session with the TensorFlow instance. So TensorFlow server will be running on your system. So you're gonna interact with them, with it, right? And thereafter, you're gonna get some results. So I can just try to say print me your session dot run, and you're gonna print this guy called C. So typically, what's gonna happen here is something different from what you are trying to do by directly printing the C. Okay. So in the last, I'm just going to say session dot close. So let's try to run this first, and then I will put up more inputs. So what you see now is it says the session graph is empty, add operation to the graph before calling the run, right? So there is some runtime error which is being generated. Now this was an older approach towards how we solve these basic mathematical problems with TensorFlow, right? So this is an old approach, kind of deprecated. So you created a session, you're trying to execute some operation by giving the data into this print statement so that you can parallelly do a lot of operations. But this is kind of deprecated. Now everything when you are trying to do it is automatically managed by the TensorFlow, right? So I can just say here, so previously we would have to create sessions to solve these kind of problems, but now it's done automatically. So when I'm saying but now it's done automatically, this is also referred to as eager executions. So this is like you need not to create sessions. So can I get a smiley here? So Rhythm, you have a query here? Do you understand? Sahil, exactly, it is very much similar to your multi-threading. It is very much similar to the multi-threading part here when you did say session.run, right? So it's like you are trying to create a separate session with the TensorFlow thread, and that's gonna solve the problem for us. But this was an old approach. You may see this approach somewhere, right? But you need to understand that this old approach is now deprecated, right? And even somewhere you may see the same code structure in a different way, as in with your TensorFlow dot compat dot v1 dot session object as a session, printing of the session dot run, right? So I think what we can do is we can just try solving it. So just give me a moment. I'll just see if this can work for us or not. No, so this is once again the other approach for us. I'll just check it once again and I'll see if it's gonna work for us or not. All right, so this is deprecated for us, right? So guys, you may see these two approaches anywhere here and there, but you need not to use them. Right, so with the session, make sure. Now why I'm bringing down this here, because you may be exploring your TensorFlow programs and you may be trying some snippets here and there to execute, so you may face these errors, right? So just be cautious on them. So now moving ahead, right? So we're gonna come up and understand how TensorFlow and machine learning is relatable. So guys, anytime if you would like, you can run the program in your Google Colab, right? So Google will give you one of the labs in which you can execute the programs online itself. So you can write down your program online. So that's perfectly fine. It's gonna be like you can code in the cloud. So TensorFlow tutorials, right? So we got this beginner level. So this is where we guys need to come up and explore. So these are the tutorials. We'll begin with our ML basics with Keras. So in the tensorflow.org tutorials, you're gonna go with this ML basics with Keras, right? So this is where we're gonna begin our TensorFlow. Let's write a new Python file. This goes like your session number 55B. So ML problems, and you're gonna explore something known as Keras in TensorFlow. So this is what we are going to explore, guys. So the very first problem is basic image classification problem. Then you got the text classification, regression, overfit and underfit. I hope you can recall all these terms, guys. Can I get a smiley first of all from all of you for this? So Pradeep says same problem in the Google Colab. So Pradeep, this is very rare of the rarest that it will happen, because Google Colab is not going to use your system. All right, so guys, you share. So today you share your problems in the WhatsApp group, right? I'll try to see and resolve them along with you guys. Okay. So whatever the problems you are facing, installation issues here and there, we'll try to resolve them in the group, and everyone can try to resolve it, right? Not just me. So you keep on posting your problems. Let the other people who have solved them, they also participate. So we're gonna explore this very first problem statement called basic image classification. So guys, you got this entire source code on GitHub. You can download this Jupyter notebook and you can run the program in the Google Colab. The moment you click on this Google Colab button, right? So you will get into the other part of your Google account, right? So this Colab is given by the Google with some limited space. So here your Python program will be executed as a Python notebook, a Jupyter Python notebook. So here you are, right? So this is how you get to see your file, edit, view, insert, runtime, etc. and etc. So in case you will be facing challenges, you can run the programs in the Colabs. Okay. So just to not waste time. So let us try to come up and see how we can work with this basic image classification problem, guys, right? So we have a built-in data set. So TensorFlow is going to give us this built-in data set, right? And we're gonna use that data set to solve the problem. But here in TensorFlow, you have this API called tf.keras. It's a high-level API which is majorly used to build and train models in the TensorFlow, right? So what are keras here? So TensorFlow.keras is a high-level API to build and train the models in the TensorFlow. So first thing first is what? I'm going to do some imports. Import TensorFlow as TF. Then from your TensorFlow, I'm going to import keras. So why you need keras? For creating and training the model. So anytime, right, there will be always the need of the libraries like NumPy, and to plot something, you got this matplotlib. So these are the helper libraries. They will be anytime required when you are doing your AI programs, right? So there is one fashion MNIST dataset, one fashion dataset, right? So which is basically 70,000 grayscale images. So you got these 70,000 grayscale images, right? And there are 10 categories. Categories means, for example, t-shirt. For example, there may be a boot, right? And resolution is just 28 by 28. So I think this is very easy again, right? So 28 by 28 pixels. So there are 28 arrays having 28 elements each, right? So this is your fashion MNIST dataset which we are going to explore. So what we're gonna do is we're gonna solve the problem of classification. We're gonna solve this image classification, right? And for image classification, if you're gonna solve it, you need to have your testing data and training data. So you're going to have this image classification with the training data and the testing data. So today we're gonna not see much about the logical part, how the things will work, because we're just going to come up and see tinges of TensorFlow and explore it. So there will be 60,000 images to train the model and 10,000 images to test the model, right? So this is what we're gonna explore, guys. This is our exploration for the day. So anyone having any challenge before we start our exploration, guys? Is the problem statement clear to everyone? Smiley awaited from all of you. I hope this is clear, guys, what we're going to do. So I'm going to say this fashion data set is going to be your keras dot data sets and the dot, right? So guys, what we see is that we have these multiple data sets built in, right? You see this, we have this IMDb data set here. So we are going to work on this fashion underscore MNIST, right? So these data sets are available, built in, these are all built in. Now, for this special data set, I want to create training and the testing data. So here I'll create two tuples, right? So this is how we work in TensorFlow, different from sklearn, right? So train underscore images, and you have this comma train underscore labels. Same way test underscore images and test underscore labels. Now this will not be of any query or any concern in a way that these names cannot be changed. This can be any name of your choice, but we are maintaining these two tuples, right? So one tuple is training images and training labels. The other is your testing image and testing labels. But test image can be any name of your choice. So now you say your fashion data set dot load underscore data. So load data function is going to give you these two tuples in return. Tuple 1 contains training information, tuple 2 contains testing information. So guys, can I get a smile here? But these are 70,000 in number, in a way of it that this is 60,000, this is 10,000. So your training images and training labels is going to be 60,000, and your testing images and testing labels is going to be this number called 10,000. So let us very quickly see in case it is correct or not. So I'm gonna say print me the length of training images, comma the length of training labels, and similarly we'll see the length of testing and the labels. So here we are, right? 60,000 and the 10,000. So we got this data set divided. So overall 70,000, right? But this is how you have divided the data. Now, typically, we don't know what exactly is there in the data set. We are just exploring the data set here, right? So as of now, what we are doing is we are exploring data set. So this data set exploration is going on for us. So moving ahead, we are going to come up and somehow write the labels which are available, but the labels you can see here only. So this is the data set, right? So this images, they are like 28 by 28 pixels. So we have this data set, and these are what we got as in the labels. So 0 to 9 are labels. So what they mean? They mean t-shirt, top, trouser, pullover, dress, coat, so on and so forth. So I'm just gonna use these class names here only. I'll just take the same list here. So these are the labels. So these are the class names, but the labels will range from 0 to 9. So for your ML model, the labels gonna be 0 to 9, but what are their names? So we have mentioned, we have mapped that here. All right. So what is what? Now the next thing for us is that we just see one of the data set, right? I mean to say, I'll just say print me training images of 0. So I'll print the training images of 0. I'll print the training label of 0. So same way, I'm gonna say print me class names of 0, right? So this is where I'm going to say print training image 0. So we are checking the 0th image, right? We're printing the data in the 0th image, and let's see what it is. So here you are, guys, right? So training image 0. So this is your training image 0, and the label is coming as 9, and the label is coming as 9 only, right? So my bad. So this is going to be your training labels of 0. So this is how your class name is going to come up for us. So it's an ankle boot, right? So it says that this training image 0 with a label 0, and this class name comes out to be ankle boot for us. Remember, this data split which has happened is randomly, right? Always understand this concern here. So when you try to kind of break this data set into training and testing, you will always get this session or any data set randomly broken. Okay. So what is this next thing which we are going to talk here is we will try to plot this on the subplot. We'll see what exactly this image is, right? So I'm just gonna come here and say plot dot subplot. Let us have a subplot, and I'm gonna take 2, 4, and 1. So your plot dot image show. So which image you would like to show on the graph is this training images of 0, right? So let's say plot dot show. So guys, you can see that this image is your ankle boot here, right? This is the ankle boot exactly. So this comes out to be perfectly fine. So same way you did this for your images of 0. Let's take one more. Let's say images of 3 and the label for the third person, right? So I'll have this another subplot. Let's say this is going to be 2, 4, and 2. So let us have these images of 3 shown here. So here we are, right? So this is address. So what I feel is, if you want, you can just write a loop and kind of try to, show some of these images, and you can just explore the data set, right? So just execute a loop and see some samples in the data set, right? So you can do that, I think so. We've already seen such part. So in case you don't want to see the colors, so you can even come here and say show the image. So color mapping is going to be your plot dot cm dot. So we have this gray underscore r. So just give me a moment. All right. So let me just try to run this program once. So here you are with the grayscale image, guys, right? So you can even check with the grayscale images, right? So these are very low resolution images. They are not that high resolution images. They are 28 by 28 as in your entire part. So the next thing is that we are going to come up and somehow create. So this, I'll comment this plot dot show. So what we need to do next is create ANN. So we need to create an artificial neural network, right? And we know what is there in ANN. So in the ANN, you have an input layer, you have a hidden layer, and you have an output layer. I hope guys this is clear to everyone. We did see while creating the XOR implementation. Can I get an acknowledgement from all of you? Artificial neural network is clear to everyone, right? So how did we create that? So you're gonna use the same technique here. So we'll say that there is a model. We're going to create a model which is Keras dot sequential. Now in the sequential model, you are supposed to pass a list of your layers, right? So input layer, hidden layer, and the output layer. So what I'm gonna do is I'm gonna say that the input layer is going to be Keras dot layers dot flatten. So flatten is the layer which is going to flatten the array. So when I say flatten, it means convert your 2D arrays into 1D array, right? So this input underscore shape is basically 28 by 28 for us. So guys, why I'm saying 28 and 28? So if you want, you can just also say print me training images of 0 dot shape, 3 dot shape. So just give me a moment. I'm gonna run this program here. So here you are with the shape as 28 by 28. So guys, can I get a smiley here? So it's 28 by 28. So the very first layer is going to flatten your inputs into 1D array. At the same time, I'm also going to do one more mathematical operation on the data set, right? So what is that mathematical operation on the data set? Let us see that. So I'll say, let us divide the images in the training layer and the testing layer by 255. So I'll say, train the images, train images is going to be division by 255. We'll put a dot 0. Then same way you have this test images, which we will be dividing by 255. So guys, can you tell me that why I am dividing this data by 255? So we'll print this training images of 0 and training images of 3 after you have divided, right? I'll just print and see what is the output. Anyone who can just try to put up that why we are doing division by zeros? I mean by 255. So what happened after you divided the data by 255? When you divide it 140 or 152 or 83 or 100 by 255, you got some floating point value, decimal value, right? So typically your data set is now fuzzy. So what I'm saying is we have sort of obtained image, let's say values between the range of 0 to 1, right? So I divided this by 255 because my max pixel value can be 255, the RGB value. So you kind of implemented a fuzzy technique. So fuzzy says that data should be in the range of 0 to 1. So can I get a smiley from all of you? So this will be more easier computations as compared to computation on the larger numbers. Now the flattened layer is the very first layer. We call it the input layer, right? So this is my input layer, the flattened layer. Then I'm going to have this hidden layer, which is going to be Keras dot dense layers dot dense. So here I'm going to choose 32 neurons. So there will be 32 neurons, right? With an activation function, which is your TensorFlow dot NN dot rectified linear unit. So this is my hidden layer. You can anytime change the number of neurons and see how your model behaves as in performance. right? So you can change these neurons, number of neurons here in the second layer, and you can see whether performance goes up or down. Now, in my last layer, which is my upper, I'm going to say Keras dot layers dot. Time I need 10 neurons. Why I need 10 neurons? Because guys, here I have 10 labels, 0 to 9. There are 10 different classes, and we know there is an activation function called Softmax, right? Which actually converts your outputs into probabilities. For 10 different classes, it's gonna give us the probabilities, right? So tf dot nn dot softmax. So welcome to the TensorFlow, right? So where you see that you need not to write activation function, you need not to worry about here and there, it will be taken care automatically. So guys, now your model is Keras dot sequential, right? So your ANN, artificial neural network, is a list of input layer, then the hidden layer, and then the output layer. So you're gonna give this list into this sequential object. So your sequential means that you are going to create an ANN on this input layer, hidden layer, and the output layer. Guys, can I get a smiley from all of you? How you can write an ANN with TensorFlow? Wonderful. Now there is an additional part here for us. In the TensorFlow, you have to compile your model. So this is like creating the model, right? So this is where we have to understand creating model in TensorFlow. Second step is compiling the model. So in the model compilation, you just say model dot compile. So guys, this model dot compile is a built-in function with this model, I mean sequential object from the Keras. You got this built-in function. So here you need to pass something known as optimizer. I'm passing the optimizer as Adam. Now Adam is an algorithm. It's an optimizer algorithm. If you will see here, so I'm just gonna say Adam optimizer. So Adam optimizer is typically, so just give me a moment here if I can just find a good link on the same. All right, I think we can open this part only. So this Adam is an optimization technique, right? So it's an algorithm. So how mathematically you are going to, kind of solve the problem statement and just ensure that your model becomes more optimized towards your data set, right? So I'll just put this link across here. So the way you got an optimizer, in a similar way, there is this guy called loss. So for the loss, there is sparse categorical cross entropy. So I hope you understand the term entropy, right? So guys, here the algorithmic approach, the mathematical approach for the losses should be sparse, categorical, cross entropy, right? Again, mathematical formulas here. So this mathematical part you need to explore, right, if you want, but not required. So in the matrix, you're gonna work with accuracy as the parameter, right? So this is what is the compilation for your model. So if you will compile the model, you are trying to optimize your model, you're trying to figure out the losses, and you have to supply a matrix. So you want to work on accuracy. Once it is done, thereafter you train the model. So from sklearn to the TensorFlow, we have a different approach. So in the sklearn, you create a model, right? You fit the model with the data and you start predicting. But here you need to write an ANN first of all, then you create a model. So in training of the model, so we use the same terminology, model dot fit function. So you got this fit function. So you have these training images and you got these training labels. Now, in order to achieve a better accuracy, we try to train the model again and again. So we call them as epochs. So the more the epochs, more better the model becomes, guys, right? So this is like training the model, but here it is trained multiple times so that your neurons they actually can make up the correct and the best possible decisions. So this is one introduction to TensorFlow. When I say TensorFlow, it's all built in, right? We are not bothered about what is what and how it is going to work for us. So next thing is, once you have trained the model, right, you check for losses and accuracy of the model. So how you gonna check that, right? So in order to do that, you will have a loss parameter. So on your testing, you will have a loss, and on your testing, you will have an accuracy, which is going to be your model dot evaluate. Guys, you're gonna evaluate. So evaluation will happen on your test images with the test labels. Okay, so let me check. So my bad, this is your test labels. All right, so now so I'm just gonna say print loss. This is your test under loss. So losses and the accuracy. But for us, the major parameter is accuracy because we are going to come up and check for the accuracy, right? It's gonna be a percentage for us. So let's try to run the program and see how it's gonna work for us. So what you see is that the model is working, and in between you will see that there is an epoch which is getting changed. So this I'll just make you guys see in the end, guys. Let this get finished first. So this is like training the ANN, right? So it's gonna take time for us. So 5 epochs means 5 iterations. All right, guys. So please have a look here. So epoch 5 by 5. Then if you see epoch 4 by 5, I hope this is clear now. So every time we are training the model, right? So you are actually working on accuracy. So what we found is that there is the data loss of 39%. I mean, there are some losses, but the accuracy of the model comes out to be 85%. So that's wonderful, right? It's not a problem at all. So we can start making predictions with the model now. So you want to make predictions with the model. So you say prediction design model dot predict. So this works same way, the way we have done it in sklearn. So you have these test images. So you make predictions on test images, right? And what I can do is I can just try to get one of this test images. So the way you got this, so we got this test images of 0. This is your test images 0 dot shape. This is your test labels of 0 and test labels of 0 class name, right? So same way, what I'm gonna do is I'm gonna use this predictions of, so for this test images of 0, right? So the label is going to be predicted for us. So I have these two things, right? Predictions of 0 for test images 0, right? I'll just don't use this. Let us see what we get here. So with every epoch, you see accuracy will increase, guys. So it just goes up, down, losses are evaluated in a different way, right, here and there. So this is also something which is a parameter in our hand, that how many times you would like to train your model. So this is okay. So what I think is, just give me a moment here. Just give me a moment, guys. So I want to come up and do the prediction. So but there is a challenge here. So predictions is going to be kind of 10 probabilities for me, right? So my bad. So if you'll see here, I got an error in the end. So predictions here are 10 different probabilities. If you can see here, right? It's a list of probabilities. So we understand that the test level 0 was 9, which was an ankle boot. But when I printed this predictions of 0, it's a list of probabilities. Why 10 probabilities? Because of Softmax. List of probabilities, right? And guys, I see the max probability for this index 9 only. So 0 to 9, right? So this 9.1, right? So anyway, so what I'm gonna do is I'm gonna say index assign numpy dot arg max. So max argument from this predictions of 0, right? So I'll get the index of the list. Now what I can do is I can just say print me the class names from the test labels of the index, right? So this is how I'm going to solve this problem. And let us run this code. So here we got it as sneaker somehow. Why it should be a sneaker? So 1, 2, 3, 4, 5, 6, 7. This is the highest one only, right? So just give me a moment. Let us see sneakers fall into which category here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But yeah, I think this is the max which we are getting. I think made a false prediction here, right? Let us try with some other parameter as well. So I'm just gonna go with this another testing. Let's say go with the 3. So we do have an 85% prediction model. So let's try with some other sample. since you have a lot of data to be tested, right? So there are 10,000 records, and of course, right? So we have accuracy of 85%. So 15% there will be some of the samples which may not be predicted well. So out of 10,000, I'm just checking for this index 3, right? The fourth item in our data set. So this is sort of not coming up good for us. All right, guys. So you just need to come up and somehow run few more iterations and see, right, that how it's gonna work for us. But when I'm trying to come up and see this list of predictions, right? So this is list of probabilities due to Softmax, right? So here we are just trying to come up and predict on the basis of probability. So I just try to got the maximum for these predictions of 3, right? And we got the index, of course, but this is the prediction, and I think this prediction is not accurate. So you need to just see few more part, because there are 10,000 of these items for us, right? So guys, can I get a smile here? So did you understood that how we can work with the TensorFlow? And I hope this is clear. In our session 55, we just saw a very basic constant creation. Then we did see how we can represent a tensor. A tensor is represented as arrays, right? So tensor is nothing, it's an array, it's an n-dimensional array. So with the TensorFlow, you have these APIs like matrix multiplication, add, subtract, multiply, etc., etc. You can do all those NumPy array operations with your TensorFlow as well, right? But of course, having these operations done with the TensorFlow, they will take more time, because TensorFlow is a big framework as compared to NumPy. So in the session number 55B, we did see how we can work on one of the very basic image classification problem. So this is already there on the TensorFlow.org tutorials, Keras classification, right? So this is the link which I have followed to explain you that how classification will work for us. Same thing they've explained, guys, here, right? If you see, so training the model and making the predictions. So I think they have just taken one more approach here. So just so we did the same thing, but okay. So let me just try doing the part the way they have done. So just give me a moment here. So we got these predictions here, right? So they created a probability model, which is going to be a Softmax, but with the model. And thereafter, they made a prediction. We didn't do the predictions beforehand. So predictions they are doing with some different approach. So just let's try to come up and see if it's gonna work for us or not. So print predictions of 0 and print the test labels of 0, right? And if you want, you can even say class names of this fellow. And class names of test level 0. So let's try to run this code once again and see, guys, if it's gonna work for us, right? So they have created another model, right, with a softmax, so that we can get these probabilities, and from the probabilities we can try to come up and detect that. Yes, exactly. So this is how we are able to get the exact output, guys, right? This is the way you need to make the predictions. So some changes here and there, right? So this is how, and guys, you can continue this further. If you can see the tutorial, this tutorial here is in more continuation, where you can always try to see the probabilities for various different products, right? For example, the ankle boot, the probability came out to be 80%. For pullover, it was 100%, right? So you can just do the predictions in a much more better way. So what I would recommend is you can try getting data sets from Google exploration for some images on flowers or animals and see if you can predict. So with this itself, when we are trying to work with TensorFlow ANN models, so there are a few more ideas on which you can work. So vehicle detector using the convolutional neural networks, right? And making a predictive keyboard with the recurrent neural networks, human activity recognition. For example, there are some children play school, they are sitting and they are fighting with each other, so you can just see the human activity. Then in the credit card fraud detection, we can have these API called auto encoders in the Keras, right? So with the TensorFlow, you have these 4 more ideas to work on with your projects, right? So just listed them here. So this is going to be all for the day. I hope you have enjoyed the part of TensorFlow. Now you can post your queries in the group. We'll try to resolve them individually and see in case if it's not gonna work, right, then what is the problem for which it's not gonna work. Thank you, guys. Have a wonderful time ahead. Bye bye, guys. Thank you.